Welcome back to Quantitative Reasoning, Unit 2.2, Subsets. After this lesson, we're going to recognize what subsets are and use the notation for subsets. We'll also learn about proper subsets and use its notation. We'll determine the number of subsets in a set and be given a formula for that. And we'll apply some concepts of subsets and equivalent sets to infinite sets. So first we have a symbol. It's kind of like a sideways U with a line under it. And that says subset. A is a subset of B if every element in A is also in B. When we put the line through it, that means is not a subset. So we want to determine whether or not these are subsets. Is A subset of B? Well, it has the 1 and the 3, the 5, and the 7. Everything in A is also in B, so it is a subset. A has a letter in the word proof. B is a letter in the word roof. Is A subset of B? No. It's not, because the R, hold on, let me erase. The R matches, O matches, and F matches, but there's no match for P, so P is not a subset. The next one says A has X such that X is a planet of our solar system. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. 1, 2, 3, 4, 5, 6, 7, 8. I believe that's all of them. So yes, it is a subset. A subset can be everything. A is not a subset of B. These match, but these are not in B. Now, a proper subset has the symbol without the line under it. Set A is a proper subset of set B and is expressed A is a proper subset of B if A is a subset of B and sets A and B are not equal. Okay, so subset, a proper subset is everything except the whole set. Notice the similarity of these symbols. We have proper subset and subset, and it's very similar to our algebra symbols, less than, or equal. So subset has the equal on it. Proper subset does not. Proper subset doesn't work if they're equal. So we want to write subset, proper subset, both, or neither in the blank. A is a person and that person lives in San Francisco. X such as a person, and X lives in California. Everyone in San Francisco live in California? Yes. Is everyone in San Francisco equal to everyone in California? No. So it is a subset, but it is not a proper subset. The next one, we have the numbers 2, 4, 6, and 8. They are exactly the same. So it can be a subset, but it is not a proper subset. This one could be both. I guess I need to fix that. It could be a subset or a proper subset because it's not equal, and that's why it's both. Here we have X is a man and X is a woman. That is neither. You can't be both. Well, at least you didn't used to be able to. All right, A is the set of all numbers, natural numbers, between 3 and 10, not including them. That would be the numbers 4, 5, 6, 7, 8, and 9. B is a set of natural numbers between 2 and 16, so that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All of these numbers are in here, so it's definitely a subset, and it's not equal to it, so it's a proper subset. So this one will use both. So what is the difference between this symbol and that symbol? Remember, this one means is an element of, and this one means is a subset. So 4 is an element of the set containing 4 and 8. Has a different meaning than the set 4 is a subset of the set 4 and 8. That's different because the set 4 is not an element of that set. All right. Empty set. For any set B, empty set will always be a subset of B. For any set other than the empty set, it is also a proper subset. Here we're having the number of elements in a set and all the distinct subsets. So if this is my set, it has no elements and it only has one subset. If this is my set, it has one element. It could have a subset of empty set or itself, which is 2. If I have a set with 2 elements in it, A and B, I could have subsets with nothing in it, with A in it, with B in it, or with both in it. And that's a total of 4. If I have 3 elements in my set, A, B, and C, I could have 1, 2, 3, 4, 5, 6, 7, 8 subsets. When you're listing your distinct subsets, it helps to find an order to do it. Here you notice they started with nothing, and then they did all the possible 1-element sets, and then they did all the possible 2-element sets, and then 3-element sets. Okay? And they listed all these alphabetically so they didn't accidentally duplicate one. There's a formula for the number of subsets, and that formula is 2 to the n, where the n is the number of elements in the set. Now, the proper subsets is all the subsets except the one that actually is equal. So when we're looking for the number of proper subsets, we do our formula 2 to the n, but we take away 1 because we subtract that 1 equal set. So here we want to find the number of distinct subsets and proper subsets for each set. So first we have to find n. There's 1, 2, 3, 4, 5 items in that set. So the number of subsets is 2 to the 5, which is 32. And proper subsets would be -1, so 31. Here we want all natural numbers between 9 and 15, including 9 and 15. So let's see. 9, 10, 11, 12, 13, 14, 15. Looks like our n is 7. So 2 to the 7 would be 128. So the proper subsets would be 2 to the n minus 1, 127. X is a prime number less than 14. So let's see, that'd be 2, 3, 5, 7, not 9, 11, and 13. 1, 2, 3, 4, 5, 6. So there are 6 of them. 2 to the 6th is 64. So proper subsets will be 1 less than that, 63. That's it for today. Have a great evening.